Welcome back, ladies and gentlemen. This is Dr. Robinson, and today we are going to continue our study, and this time we're going to talk about scientific notation. So, first thing, scientific notation is a way to abbreviate very large or very small numbers using the power of 10. When we're talking about very large or very small numbers, we're really talking about the magnitude or the size of the mathematical numbers or objects themselves. A number written in scientific notation, it consists of two parts or two factors. The first factor is a number greater than or equal to 1, but less than 10. It's going to be multiplied by the second factor, which is a power of 10. So remember, the first factor is going to be greater than or equal to 1, but less than 10. And it's going to be multiplied by the second factor, which is a power of 10. So it's 10 to the something power. Standard form, a number written using digits and place values is the standard form. In other words, that's the regular way we write numbers. For example, here we have 8,900,000 written in standard form. If we wanted to change that to scientific notation, remember the first part is greater than 1 but less than 10, so that would be 8.9 times 10 to the 6th power. And notice 6th power is a power of 10, which is the second part. And where did the 6 come from? Is because not there are 6 zeros, there are 6 places that are behind the decimal, and we're going to get the steps in a second. So standard form versus scientific notation form. And notice the positive exponent deals with very large numbers. So when you have a magnitude that's very large, then you have a positive exponent. Whereas the number 0.00005230, that's a very, very small number. If we change that to scientific notation, we have 5.23 times 10 to the negative 5. So that negative indicates that is a very, very small microscopic number. So it's very small. So the magnitude is negative. So notice the exponents. So the rules and steps on changing to scientific notation. Here we have 172 billion, and we want to change that to scientific notation. Here are the steps. Step 1, put the decimal after the first digit. So right after this 1, we're going to put a decimal point right there. And we have 1.72 and all of those zeros. But remember, the first number has got to be between 1, it's got to be greater than 1, but less than 10. So that's why we put the decimal there. That'll be 1.72. Step 2, we're going to find the exponent by counting the number of places from the decimal to the end of the number. We're going to count the decimal point. Now remember, a large number has a decimal point at the very end. So 172 billion had a decimal point at the end here. So if we counted the decimal places from the end all the way to between where we put it, between the first and second number, between the 1 and 7, that's approximately 11 places we moved that decimal point. Step 3, drop the zeros to get the coefficient, that's the first number, multiply it by the base, which is always 10, and include the exponent that you found in step 2. So we took 1.72, which is the first factor, a number between 1 and 10, between greater than 1 but less than 10, and we're multiplying it by a power of 10. Remember, the power is always 10, and the base is always 10, but the 11 came from all the spaces that we counted from the end of the number to where we put the decimal point in between the first and second spot. So our answer in scientific notation would be 1.72 times 10 to the 11th power. That's a big number, and that's how we write it in scientific notation. So here's the example. Jupiter. Minimum distance from the sun is about 460 million 100 miles. What is this? What is that number written in scientific notation? So there's a picture of Jupiter, and we want to see how many miles in scientific notation is that so from the sun. So the first thing, we have this large number, and we want to remember the decimal point is already at the end, and we want to put it right in between the first and second number. So 4 would be a number that's greater than 1 but less than 10, and we still have a couple other digits. We have a 6, we have a 0, and 1. So that would be 4.601. That would be our first part of the number. Now, since we have this number 460, 100, and 3 more zeros, let's get a pen, and remember, let's get a red pen. And remember, the decimal point is at the end, and we're going to count over our spaces to where we put the decimal point. 1, 2, 3, 4, 5, 6, 7, 8 spaces. That is where the decimal point would be in between the 4 and the 6. So our answer would be, our first part would be 4.601 times the base of 10, and we counted over 8 spaces. So our answer is going to be 4.601 times 10 to the 8. So let's look at this question. See if you can try it on your own. Oh, check for your understanding. Make sure you understand what we've done so far. If you're uncertain, rewind the video, watch it again. Here's a question. Miss Bolden measured a specimen that was 0.00000045 millimeters long. What is the specimen's length written in scientific notation? So there's the specimen, and here's our number. See if you can write that in scientific notation. So do you notice this is a very, very small number, and small numbers are going to have negative exponents. So we have a decimal point here already, and we're going to put it between the 4 and the 5. So this will be 4.5, which will be our first number because 4 is greater than 1 but less than 10. But notice we moved it from this spot of back to in front of the 4. And remember, if it's really, really small, it's going to be a negative exponent. So can you count the places over from there to where the 4 is? Let's count. 1, 2, 3, 4, 5, 6, 7. That's right. If you said 7, great, but it's going to be -7 because it's a small number. So that'll be 10 to the -7. So our first part is going to be 4.5, and our second part is going to be 10 to the -7. So if you said your answer was 4.5 times 10 to the -7, nice job. Here's a question we'll pick up tomorrow. What is 3.5 times 10 to the -6? See if you can figure that out. We're going back into standard form. See if you can go backwards. Remember, check for your understanding. Watch the video again if you need to. Write your questions down. Here's another question that I think is pretty good. What is 4.01 times 10 to the 0 written in standard form again? Here's a nice question about the Amazon River. So change that to scientific notation. So we've come to the end of our program. I hope you got something out of it. Remember, bring in your questions, and if you have something that you are still uncertain of, please write it down, and I'll be glad to answer it. So this is Dr. Robinson, and I'll see you tomorrow. Bye-bye. Bye-bye.